Okay, so here's a little bit about myself. Prior to starting SN126, which is a company that focuses on helping developers deploy bug-free code, I was an engineer at Twitter, where among a bunch of other things, I built a tool called Diffie for myself, primarily motivated by the fact that I didn't like writing tests. So I wanted to come up with a way that my code wouldn't break in production and would give my team the confidence to allow me to ship big changes to production faster. We're going to dive right into the code today. Before we do that, I want to do the poll now. Courtney, so if you could just post that. Just a quick poll on how many of you have, written Spring Boot tests before. Okay. Great. So it looks like the majority of you have written Spring Boot tests before. So this should be sort of familiar territory for most of you and should not require a lot of motivation. So here are the results. But for the benefit of those of you who haven't, I'll still go through very briefly what the structure of that test looks like. Okay, so here's a sample service, a simple, a small piece of a service. So this is a user controller with two endpoints, get endpoint and a post endpoint. And this controller is backed by a repository. In this case, it just happens to be a Mongo repository, right? And there is no implementation needed because Mongo repositories will come with default implementations of these basic CRUD methods. So now let's see if you wanted to test this using a Spring Boot test, and I'm just going to focus on the get endpoint in this particular scenario. What we end up doing is, creating the first, we end up deploying a server. So the Spring Boot test will deploy a server on a random port, which is pretty neat. And then the Spring framework also gives us access to this test rest template. And then, I can, go actually, send a request here. So this test, sorry, one second, my deck decided to jump ahead on me. Yeah, okay. So this test rest template basically allows us to interact with the server by sending it some requests. And that's exactly what we're doing here. In the first bit of the test here, we're creating a stub user object, and we're saving it directly into the repository. So this is the equivalent of setting up the data so that the request is something that that can be successfully executed when the server decides to, or when the controller decides to talk to the repository. So this is actually invoking a MongoDB call right here with the save invocation for this particular stub. And then when we get a response back, this is all the way at the HTTP level, right? We are then able to make assertions on this object that, okay, the object that we saved in the repository, when we retrieve that object with this particular ID, we end up making all these assertions. So this is fairly tedious because you have to set up this data, and then you have to make all these assertions on the response that you get back. Without setting up this data, this request would not be able to execute correctly. And then in order to make sure that all the logic, if there were any, right, then the assertions are needed to make sure that the logic is working correctly. A step sort of along the evolution is that you, instead of deploying the server, now you just want to mock the behavior of the repository. So you're not actually writing to a MongoDB instance. So you don't want to be running a MongoDB, a real MongoDB instance locally on your machine. when you're running these tests, or you may not have one available when you're running this in your CI. So what you want to do is you want to mock the behavior of the downstream dependency here. And so the work required is pretty similar, right? Like you still need to mock the behavior of this user repository. This time, instead of auto wiring it, you're using a mock bean, and then you're stubbing the behavior of this mock with the stub that you created here, right? So the amount of effort required is still pretty much the same. And this doesn't change regardless of like which mechanism you use to create this kind of data and keep track of it, because ultimately what it boils down to is that you're manually thinking of all the different scenarios that you have to test, and you're creating these stubs and maintaining them. And this can be pretty tedious, right? This is a pretty simple example that I picked where the user object has only a handful of fields that you can count on your fingers. But you can imagine from your regular projects how complicated these schemas can be. Deeply nested schemas that we work with our customers are anywhere from like a few hundred to thousands of deeply nested fields, right? So for the purposes of sort of integration testing, if you try to maintain data sets that are that large, it ends up being tedious. So typically you find ways to move all of that data out of your code, but you still have a significant amount of responsibility to maintain the life cycle of that data and figuring out like how to wire that back in to the test flow and how to get that thing to work. So taking a step back, the problem that we are motivated by here is to make sure that our code doesn't break in production, and that's easy to do when our code only does a handful of things, right? We can just test things by hand and not even bother with tests. But as our code matures and it starts getting deployed with real customers, we cannot afford to have outages, and the cost of manual testing just becomes prohibitive. We start writing tests, and that's great because that's a very useful investment. These integration tests will make sure that all the different cases that your code needs to cover are being covered. And as your code becomes even more mature, it starts doing more things. Now you're talking exceeding a few thousand lines of code. In that particular situation, now you're in a place where your code is doing so many different things because there's so many different combinations of paths that the request would take through your code, through the combination of all the different classes that have to work together to respond to a request, that it becomes humanly impossible for you to track every single corner case that is going to be exercised in production, right? And so you may look for like automation solutions in this kind of situation, but the problem that you're solving isn't really automation, right? Like there's plenty of solutions out there that can automate the hell out of whatever test you've written. The problem is you haven't written enough tests, right? So if you've got, let's say, a test suite of 150 integration tests that are like these tedious things like with all the stubs and whatnot, you can't run 150 tests 100 times and pretend that that's the same thing as having 15,000 different tests. And that's actually a real number. Like we see customers having anywhere from 10,000 to 20,000 different scenarios being exercised in production. And so the problem that you have is enumeration. It's not automation, right? And enumeration, whether it is something that you track manually in a low code, no code way, as long as humans are involved, it ends up being a very low cardinality set because you have to keep track of everything with yourself. So the compromise you typically end up making in this kind of situation is that you realize that there's a finite amount of bandwidth you have during your development process, and you identify the key scenarios that you absolutely cannot afford to have be broken, and you just make sure that these scenarios work, and then everything else ends up being a Hail Mary pass into production. So as you start increasing your shipping velocity and you start, getting faster and faster deploys into production, you're targeting continuous deploy, so to speak. You start seeing patterns of rollbacks happening within an hour of a deploy, right? So 30% of all your deploys are getting rolled back within an hour, and that's a result of you moving at higher speed than what you can control in terms of quality. So now you need higher quality, and what you really want is to make sure that there are no surprises in production, and anything that can happen to your code in production has already happened to it before you deploy to production, right? That way you won't have any surprises. And so that's where we've built a framework, a library called Isotope, that basically observes your code's behavior in production as it gets deployed with your code, to learn all the different patterns that your code is going to exercise in production, and then bring that knowledge back to you as tests in a simulated environment. And when I say test, I literally mean a test, and I'm going to show you what this looks like in a moment. And then report back to you any unexpected patterns that would indicate breakage. So mind you, we're doing this completely offline. So we learn in production passively, but the testing that is happening is completely offline, right? Because just like any other test that you run, it gets run locally on your laptop, it gets run in your CI system. It happens offline. It doesn't require you to connect to production environments. So how do we do this? Well, let's imagine that you've got a service that's running in production and it's receiving traffic. And in order to serve this traffic, it has to talk to a bunch of downstream dependencies. And what Isotope does is it builds this box around your service where it's able to watch all the incoming traffic, incoming requests, outgoing response, and also at the same time, looking at all the downstream interactions that your service is having in order to serve that request. And as it does that, it is recognizing that there is a lot of repetition happening in production. So there is millions of repetitive things happening in production, millions of events happening in production, and it reduces them down to a few thousands of distinct patterns. And then it uses that knowledge to create these offline simulations where the behavior of the downstream dependencies can be automatically mocked and stubbed. Right? So you don't have to write extensive mocks and stubs for the downstream dependencies. And then it is, because it already knows what the correct baseline behavior is based on what was observed in production, it is able to automatically create all the assertions for you in terms of not just the behavior of the top level response, but also any side effects that you might want to make assertions on downstream. So let's say you've got an update user request. You want to make sure that the user was actually updated in the database, and that actually that call actually went through. And so Isotope would learn that behavior from production and then make sure that that assertion remains valid in the newer version of your code. So then, it basically, after doing this comparison, it is able to give you a report in your test. So just to, sort of crystallize this into a concrete example, one of our users is an online marketplace where their customers are constantly trying to game the system by, trying to apply expired coupon codes. And these expired coupon codes, I'm personally also guilty of this. Anytime I see this field, I have to do a quick search to see if I can find a code. And inevitably, every time I get the same message back saying that the code is already expired and try a different code or whatever, it never worked. And that is the correct behavior of the system, right? Because otherwise the company would lose a lot of money. In one of the changes that they were about to ship into production, they would have accidentally started accepting these expired coupon codes into production, right? And they did speculative analysis on this and figured that their observability tools could not have helped them in this kind of situation because there are no exceptions being thrown. right? So there are no PagerDuty alerts. There's no, GC pressure, no instances running out of memory or, disk failures that are causing, instances to fall over. So observability tools don't help you in this situation because there's a very subtle breakage in business logic. And by the time they would have found out, the only way they would have found out was if, when their finance team ran the numbers a month later and came back to them and asked, like, guys, how come the transaction volumes are going up, but the revenues are going up? And they estimated that by that time, they would have already hemorrhaged more than $1 million a week. So this was like a $4 million bug that they were able to prevent from shipping into production because they had, isotope watching out for them. So, how does this work in terms of integration, right? So I showed you that, REST controller at the beginning of this talk, right? So the way you would integrate isotope is by adding this annotation with your controller at the beginning. And there are sort of more fine-grained ways where you can also, like, for example, for any reason, if you don't want to monitor the entire controller and all the endpoints in the controller, you can skip adding this annotation to the class, and you can add an alternative annotation to the methods directly here, and so only those methods will be observed by isotope them. So you have like fine-grained control over what you want to observe. And as isotope is able to now observe this, the task that remains is like, what do we do about the downstream dependencies? So for the downstream dependencies, if you've got these repositories or external clients, you have a similar way of looking at them. You can annotate them with this bottom annotation, and then isotope is able to observe the behavior of these downstream dependencies. So now the question is, right, like, now that we've observed what's coming into the service and what's going out of the service, how do we use that knowledge to run tests? Right. This is what a test would look like for isotope. And what this test is doing is, it's basically saying that isotope test driver.top user controller class, right? So here it's saying I want to test, I want to include the user controller in my test. If I wanted to include other controllers, I would just add similar registries at this setup method, and auto-wire those dependencies here. And then all I have to do to run all the different scenarios that I've learned, like all the different patterns that I've learned for all the controllers in my production environment, is to invoke this one line, right? Run sequential, or I can even do run parallel if I want to run tests in parallel with fine-grained concurrency control. Like I want to be running 8 or 16 tests in parallel, whatever my machine allows, so that I can get through my test faster. This internally will then fetch all the scenarios from isotope, and these scenarios are things that are either available to you locally as part of your code. I'll show you in a moment what that looks like, but also available to you through a hosted service that we provide in case you want to use that. But yeah, you don't have to use our hosted service. You can just use isotope standalone locally on your machine. And have all these scenarios be recorded locally as part of your code. I'll show you what that looks like in a moment. Again, you should notice here that there is like zero mocking happening. There is no stubbing that you are writing. All of that is happening behind the scenes by virtue of the same annotations, right? So the annotations that you added initially to observe and learn are now changing their behavior to send traffic into the service from the top, and then mocking the behavior of all the interactions from the bottom, right? And these interfaces are valuable because they allow us to capture all forms of state beyond just network calls. I'm going to show you real quick what that looks like. Okay, so this is my IntelliJ, and here are some captured samples that I can show you. So these are the recordings that you would get available to you, and you can manage them as you please. This is where this captures everything that happened in that particular request, right? It captures what the input was. So this was, the field that was inputted. This was, the response that we got, this user from this downstream dependency. So we invoked a find by ID on the repository, and that's what's captured at the top here. And then we can see at the root level, we received a request with this particular ID, and it invoked this get by ID method at the top, and returned this object, which is user, and has all of these details in them, right? These are sort of the kind of samples which capture everything that happened for that request and make basically define a test, right? So this entire, like all of this data is basically one particular scenario, and similarly you can imagine having like thousands of these scenarios where all of them are automatically being generated through usage of your code. And that can happen locally on your laptop. It can happen in your staging environment where you're doing like any kind of dog fooding, or you've got like your QA is doing some testing for you. So all of that can happen there, or it can happen in your production environment also, where real users are lighting up every single corner case in your code base, and you're getting like that breadth of data. So yeah, that's a quick overview of how we can get a lot of coverage for Spring Boot without having to write these tests manually. I would like to take a pause at this point and answer any questions that the audience might have.
Hi,
Hi, Dimitri.
Hi. Can you hear me?
I can hear you. Yes.
This is really cool. What about personal identifying information that could be part of the traffic, right? That hits the service. All of this will be captured by your tool.
Yeah, great point, Dimitri. So, well, we by default, yes, but Isotope provides you with the redaction annotations that you can add to your models. So whatever entities are being captured, they like deeply nested fields within those entities that contain PII data can be annotated with a redaction annotation that's part of the Isotope SDK that will redact that particular field to whatever default value you provide, right? So that way, any data that gets captured will be masked and redacted before it ever leaves your production environment.
Understood. Thank you.
You're welcome. What does a test failure look like? Well, okay. So let me show you 1 second. So I'm going to show it to you here. So when you run the test, it just tells you that particular test failed, but that's not very useful, right? Because telling you that a test failed or a particular endpoint failed is not specific enough, and the feedback needs to be detailed, but at the same time consumable from a human point of view, right? So that's where like the Isotope UI helps a lot, and I'm going to show you that 1 second. So you should be able to see my screen now. So I'm just going to quickly log in. So here you can see all the different services that we own at SN126. If I take a look at my geo service, I can see all the different people who've been running tests for this service. So this is me, and I can see that, okay, this one, here's a report that has a failure. Let me answer your question by showing you what that looks like. So this get endpoint is the one that's in red, and that's the one that's failing. So if I open this up, then I can see that within the output body, the response body, there are these long parameters that are failing. So I'm only interested in things that are failing, or Noel is only interested in things that are failing. So let's just zoom in on that and filter out everything else that's broken. And when I click on this, I can see that my latitude was expected to be a floating point value, but in reality, up as an integer. So I made a rounding error somewhere along my computation. I accidentally converted this floating point value to an integer, and now I'm getting different values during my test as I should. So this is another example of unless I'm explicitly watching out for this kind of failure to happen, I would never be able to catch it on my own. And the way I would eventually find out is when my ops team on the ground who's trying to make deliveries says that they can't get their deliveries done because the GPS coordinates they're getting are garbage, right? So yeah, that's what this looks like, and I showed you what the story looked like for one of these samples that was captured in production. That was the expected value. This is what it looks like, when we look at expected versus actual, right? So now I can see that okay, these are all my downstream calls, and this is the top level. And it's the output where things are not matching up. So I can drill inside the output and see those values, and basically I can see here that I'm getting 17 and 18 for latitude and longitude, and 17 point some decimal values and 78 point some decimal values, which is what was expected, right? And also, this gives me this transaction ID, which allows me to reproduce this one scenario locally. So with the isotope.run sequential or run parallel, you're basically running thousands of these things simultaneously. But if you want to debug a particular bug, right, in this particular case, I want to see where this rounding error is happening, then it's useful to be able to run one thing and then attach a debugger to my test locally on my laptop, and then be able to step through my code line by line to see where things are failing, right? And these transaction IDs are basically the same thing as what you saw as the file name in the resources, test resources samples directory, where all of your samples are getting stored. So yeah, that's a fairly long answer to your relatively short question, Noel. What does a failure look like? This is what it looks like. All right. Let's see. Coming back here. What's the URL to read the docs? Does it? Yeah. So yeah, let me share that again. Yeah, so please visit sn126.com. We have been, gradually deploying this across larger engineering teams to get quality feedback, so that the tool matures and is actually useful before we make it more broadly available. So if you are interested in using this, please reach out to us, and we'd be happy to work with you. The thing that we want from you in return is feedback and quality feedback. In the early stages of development, it's important for us to have the right partners who are going to give us good feedback, so that when we make it broadly available to everyone, it is something that is already valuable, and not something that people just write off as, hey, it's not fully baked or not well thought out. So please do reach out to us. We want to hear from you, especially this group of people. You guys are deep in Spring Boot. About 80% of you have written Spring Boot tests already. So we'd love to hear from you guys and work with you. So please reach out to us here, and looking forward to giving you access. The next question. does it have any impact on performance of the application? From Shrikant. So Shrikant, it does. It has minimal impact on performance. It doesn't show up on your CPU usage at all, and that has to do with some intelligence. Like we do progressive sampling and early filtering on the SDK, which is a fancy way of saying that our sampling rates are very low, right? We intelligently reject most samples as repetitive, and we don't have to do a lot of work to do that. We are able to figure that out very, very quickly, and we've developed like some cool ways to do that. And the thing that it boils down to is that like there's a background thread where the samples are being emitted and buffered. So that's where you may see a little bit of memory pressure, like maybe 3 to 4% increase in memory pressure, because these samples are like, we don't want to be constantly emitting things, so we do things in batch. So there is that memory pressure that you might see based on the size of the samples that are being collected. So like how big is the request, how big are the downstream calls, and things like that will end up determining the size of that. But we haven't seen anything bigger than 3 to 4%. And it's something that performance wise is well within tolerance for the vast majority of customers out there. One of our clients is a famous cloud provider, and they are using us to test their services before they go out into production, and also like monitoring their services in production with Isotope. They are in turn running fairly high mission critical applications for their customers on their infrastructure, right? So that's a testament to the amount of diligence that has been put into make sure that performance wise this doesn't blow up. You're welcome, Noel. So Chanchal, I want to share this DVD with my friends. Would that be okay? Sure. I would want you to introduce me to your friends and see if there is something we can learn from them to make Isotope better. But yeah, I mean, feel free to ask them to reach out also when you share this with them. Dmitry says, how often and for how long should you run Isotope service against the live traffic to gather all patterns to produce tests, and how do you update previously gathered samples of tests? Yeah, so Dmitry, a great question. There's a long history of evolution with Isotope where we've come across these problems, and then it took us a long while to figure out the right solutions through trial and error with customers. The thing with how long is enough to get all the different patterns is summation, because some hard code paths will get like thousands of repetitive samples within seconds, whereas the sort of long tail of rarely exercised code paths may see like one request every few hours, or maybe sometimes one request every few days, right? So it really depends on your application. But the way we typically look at it is, we want to gather everything in terms of like, the life cycle of the release. So the entire duration that your your release exists in production. So let's say you released something last week and it has been in production for a week now. Then everything that your code has seen in the last week becomes sort of one unit of learning, right? And then there is a history of these versions of your code that has been in production. So for each version of your code, there is knowledge that is also versioned by the versioning of the code, right? And then we use that to create sort of this to basically do the data lifecycle management of this, and we give you fine-grained controls, which I didn't get into about, right? Like that by default you just want to be always looking at the last release as your baseline, right? Because that's the most recent source of truth for you. but there might be things that are so rare that they didn't actually happen in the last release. They happened, let's say, 2 releases ago or 3 releases ago, and you want to be able to go back in time and bring that data for specific endpoints, for specific scenarios back into your test suite. And you want so we give you programmatic ways to be able to do that. We give you the ability to go as far back in history as you want to get different versions of your test suite for particular scenarios. Them as part of the entire test suite that is going to run when you run isotope run sequential. So yeah, hopefully that answers the question. All right, looks like that's the end of the thread of questions. So thank you so much, everyone, for taking the time to hear me out and for being so supportive. I really appreciate that. And again, if you guys want to try isotope and play with it, we'd love to work with you. Please reach out to us at this email, isotope@sn126.com, and visit our website. We would love to hear from you guys. Thank you very much.